Hi, I'm Cheryl Leach. In this problem, we're asked to sketch the graph of two functions, and then we want to find the area of the region bounded by those two curves. All right, well, the first thing I notice about my two functions is that that's all that was given to me. I was not given endpoints or an interval to look at, which means that when I go to find the region bounded by these two curves, I'm going to need to find intersection points. All right, so I'm going to begin there. Not only is that going to be helpful for my integration, but also those intersection points will be nice to have when I try to graph the function. So let's go ahead and see when those two functions intersect. You set the two equal to each other. So we're going to have an x cubed plus 4x squared equals x plus 4. Now this is a cubic, so to solve the equation, we're going to move everything to one side. So I'm going to have an x cubed plus 4x squared minus x minus 4 equals 0. Now, when I look at this, I have a cubic that I want to factor. Don't forget about the factoring technique called grouping. We don't use it a lot, but it's exactly what we need in this case. I notice that in my first two terms, they have an x squared in common. So I'm going to factor out the x squared, and I'm left with the quantity x plus 4. In the next two terms, I have a minus 1 that's common to both of them. So I'll factor the minus 1 out, and I'm left with minus the quantity x plus 4 equals 0. Now I've gone from 4 simple terms to 2 complicated terms, but I notice that these two terms both have an x plus 4 in them, so I can factor out x plus 4. So I'm going to have x plus 4 times the quantity x squared minus 1 equals 0. All right, now my factor x squared minus 1 can be factored some more. So I'll have the quantity x plus 4 times the quantity x minus 1 times the quantity x plus 1 equals 0. I now have 3 things multiplied together that equal 0. One of them's got to be 0. So if x plus 4 is 0, that means that x is going to equal negative 4. If x minus 1 equals 0, that means that x is going to be a positive 1. And if x plus 1 equals 0, that means that x is going to equal negative 1. There are going to be 3 different places where these two graphs intersect. All right, well, let's figure out what the y-coordinate is for each of those. Now remember, there's solution points to both equations, so I should be able to plug them into either one and get an answer. G of x is probably the easier way to go. So let's evaluate g of each of those particular numbers. So g of negative 4 is going to be 0. G of 1 is 1 plus 4, or 5, and g of negative 1 is going to be negative 1 plus 4, or 3. Again, you could plug negative 4 into my function f and still get 0. 1 into my function f and still get 5, and so on. So let's go ahead and plot those points on my graph. I have the point negative 4, 0, which is right here. I'm going to have the point 1, 5, which is right here. And the point negative 1, 3, which is right here. All right, so let's go ahead and concentrate now on graphing my two functions. The function g of x is the simpler one. It's a line. And I know that these 3 points are all solution points to that line. So I'm just going to go ahead and draw that in. All right, now my function f of x is a little more complicated. It's a cubic. Now, if you want to, you can go ahead and use your calculus techniques to find when it's increasing, decreasing, concave up, concave down, all of that important information. In this particular problem, though, I would really like to get to the heart of the problem. So instead of going through all that, I'm just going to use some algebra to get a rough idea of the graph. I know it's a cubic, and the leading coefficient is a positive 1. That means that it's going to begin with negative values for the output. And eventually, as x gets large, I'll end up with positive. So I'm going to start out down here, and eventually I'm going to end up getting higher and higher. Well, what else do I know about my function f? Some quick observation and maybe a little bit of factoring, you might notice that it's going to have x-intercepts at -4 and at 0. So I know this point will be on the graph, and so will this point. So let's see. I know that I'm going to start from below, and I'm going to increase. And now I know I have to go through this point because it was an intersection point. I'm now going to come down, hit my x-intercept, and come back up until I go through my other intersection point. Now, like I said, this is a rough graph. I'm not really sure that I made that maximum high enough. If you wanted to find out that detail, you could certainly use our calculus techniques to find out where the relative maximum occurred. All right, but since I have my basic idea of what's happening, I want to go ahead and get to the actual problem here, which is to find the area of the region bounded by those two curves. Notice that I have two sections. This section, the cubic is the top function, and in this part, the line is the top function. So I know when I calculate the area, I need to take the top minus the bottom. So for my area, I'm going to have the integral from -4 to -1, because that x-intercept was -4, and that intersection point had an x-coordinate of -1. So I'll be going from -4 to -1. And in this case, the top function is my cubic. So I'll have x cubed plus 4x squared. And then I'm going to subtract the bottom function, which happens to be the line. So I'll subtract x plus 4 dx. That will give me the region, or the area of that first region. Now let's move to the second region. I'm going to be integrating from -1 to a +1. So I'm integrating from -1 to +1. And this time, the top function is the line. So I'll have x plus 4 minus the bottom function, which is my cubic, x cubed plus 4x squared dx. Now that I have it set up, I need to begin my integration process. And maybe before I do that, I'll go ahead and distribute that negative across. So I've got the integral from -4 to -1 of x cubed plus 4x squared minus x minus 4 dx, plus the integral from -1 to +1, and again distributing the negative, I'll have an x plus 4 minus x cubed minus 4x squared dx. The integral of x cubed is x to the 4th all over 4. The integral of 4x squared, 4x cubed divided by 3. The integral of x is x squared divided by 2, and the integral of 4 is going to be 4x. And remember, I'm evaluating all of this from -4 to -1. The next piece will have very similar pieces to it, just in a slightly different order. So I'm going to have x squared divided by 2 plus 4x minus x to the 4th all over 4 minus 4x cubed all over 3. Evaluated, this time from -1 to +1. All right, now we need to plug in our upper limit and then subtract what happens when we plug in our lower limit. So we're going to plug in a -1. So I'm going to end up with a 1/4 plus, let's see, when I plug a -1 in here, -1 cubed is -1. So I'll have a -4/3. Then I'm going to subtract a +1/2. And then -4 times -1, that's a +4. And I need to subtract what happens when I plug in a -4. Well, when I take -4 and multiply it by itself 4 times, I get 256. So that's 256 divided by 4. Then I'm going to add a -4 cubed, multiply it by 4. That'll give me a -256, this time over 3. So -256 all over 3. When I square a -4, I get 16, so I've got -16 over 2. And when I plug a -4 in, -4 times -4 is plus 16. All right, I'm still not done yet. That was just the first piece. Now I've got to work on the second part. So I'm going to be adding this integral when it's evaluated from -1 to +1. So again, I'll start with the upper limit and plug it in. So I'm going to have 1/2 plus 4 minus 1/4 minus 4/3. Then I need to subtract what happens when I plug in the -1. When I plug in a -1, I'll have a positive 1/2 minus 4 minus 1/4, and -1 cubed is a -1, so when I multiply that by -4, I'll end up with a plus 4/3. Okay, now there's a lot of number crunching to do here, but it's just adding and subtracting with fractions. And if you notice, the denominators are 4, 3, 2s, and 1s. So I'm going to end up with a common denominator of 12. And when you combine all these fractions together, the numerator will be 253. I know this was quite complicated, but just stick with the basic rules on how you do each piece individually. Take it a little bit at a time, and you're sure to get the answer. I hope this helped. Thanks.